Hello guys, welcome back to class. So in this session, we will see the remaining portion of introduction module, plus we will do the module 1 assignment also. Right. So one important topic is pending to discuss. That is about the code optimization technique. Just I'll give you brief on how it works. Code optimization. Before that, we'll see Java comments. Comments in Java. Comments mainly for a documentation purpose. Informative, right? So whenever I write a source code, you can describe your variable. This is a variable to store something. This is a method for doing something. Like that, you can have a documentation. Comments you can do in two ways. Single line comments, multi-line comments. One is single line comments. You can do like this. And you write here, I am one line. Again, if you want something, second line, you write like this. You can also write this, but for every line, you have to keep this. And multi-line, if you go, second is the multi-line comments. So instead of using the symbol everywhere, use this slash star, then write how many lines of comment you want. At the end, you just close this. This is a multi-line comment. And these comments are restricted only for the source code. When you write a source code file, you are writing a .java file. You are writing .java file. So you are writing a hello.java. And this is what we are calling as the code inside this is called as a source code, which you are writing in English. So in the source code, you are writing the comments. What is the use of comments? Comments for our understanding purpose, right? So today I am the developer writing the code. Maybe if I leave the company, another developer will come and modify the hello.java. So other developer who is seeing your code has to understand what is this, right? For that purpose. And the comments required for us. I am a developer writing. Maybe tomorrow, if I see, I should have the information, description I need. And tomorrow, if other developer is looking the same code, they should understand that. So this is only for us. Whether comments required for JVM? Comments required for JVM? Not required. That's what compiler will do is, whenever compiler is converting your source code to bytecode, whenever compiler is converting your source code to bytecode, all the comments will be removed. So in bytecode, will you have a comments? No. Comments will be in the source code only. Comments will not be in the bytecode. And definitely, if comments are not there in bytecode means, will you see the comments in the native code, binary code? Will you see the comments in the binary code? Not at all. So comments are source code level. Okay. Now come back to code optimization. One simple program will take. So I'm taking the program hello only. Take it hello only. Done. So I'll write a comments. This single line comment. This is the program I am going to save as let it be hello.java. I am saving, guys. This is my source code. In my source code, what I am writing, first a single line comment I written. Okay. So here this is my hello program. Simply write Hello guys, welcome. Something I am writing. Okay. This is my 2 lines comment. Then hello program starts. And inside that say I'm printing hello guys. Okay. I'm declaring a variable int a equals to 10. Okay. We didn't discuss about data types variables. We will talk more details later. But at least you may have an idea. When I allocate a memory, int a equals to 10 is a variable declaration. Am I right? Int a equals to 10 is a variable declaration. Int a equals to 10 is a variable declaration. For variable a, how much memory will be allocated in Java? Any idea? Just to check any knowledge is there, otherwise no problem. It is actually 4 bytes in Java, 2 bytes in C language, C 2 bytes, Java 4 bytes. How many bytes memory will be allocated? 4 bytes of memory. This is a memory box allocating whose size is 4 bytes. And inside this memory block, it is keeping the value 10. Okay, done. Next what I am doing, int b equals to a. So I am declaring another variable b. I am declaring another variable b. Okay. Again for b, how many bytes will be allocated? For b also 4 bytes will be allocated. 4 bytes will be allocated. What value I am storing in this? A value I am storing. Whatever value in a, that same 10 I am keeping here also. Okay. Fine. Then I am doing int c equals to 10 plus 20, something like this. Some expression I am doing. 10 plus 20 by 2, whatever you want. Some mathematical expression I am writing intentionally. Now, how much memory has to be allocated for C? This expression. I'm going to print now. You see the optimization technique. So this is a very simple optimization technique. I am saying C equals to plus the C value. This is double quotation. Okay. Then okay, take up to this. Now, as per your understanding, how much memory will be allocated when I run this program internally? Simple, I think it is. You have another variable C. C also will take 4 bytes. So totally how many bytes will be allocated, guys? I am declaring 3 variables. A 4 bytes, B 4 bytes, C 4 bytes, total of 12 bytes. 12 bytes of memory. Very good. Total of 12 bytes. Okay, fine. Next, very important, interesting question to you. This is an arithmetic expression, right? Listen, think, and answer. 10 plus 20 by 2 is an arithmetic expression. Am I right? Which contains arithmetic operators, correct? Arithmetic operators are there means arithmetic expression it is. My question to you guys, who will evaluate this expression? Compiler or JVM? Means at compile time this expression will be evaluated or runtime expression will be evaluated. Definitely at runtime, right? Everybody in the world will think that only. But actually, this is called as a constant expression. Means it has only constants. In that, any variables are there? 10 is a constant, 20 is a constant, 2 is a constant. This expression contains only the constants. Do you have any variables? I think you know the constants and variables, right? In a simple math, if you take 2a plus 3b, something like this, 2 is a constant, 3 is a variable. A is a variable, 3 is a constant, b is a variable. If I write a plus b, it is fully having only variables. A is a variable, b is only variables. This expression is a combination of variables and constants. This is only variables. If I take 2 plus 3, 2 plus 3 containing only constants. A plus b containing only variables. 2a plus 3b contains variables and constants. Now tell me the expression 10 plus 20 by 2. Is this a constant expression which containing only constant values? Yes. So now what our intelligent compiler does is, compiler only will evaluate this. Compiler only will evaluate this. Compiler only will evaluate this. Compiler can do it, so it will finish it. Why again wasting time later for running the program? So if this is your program, guys, how this will be optimized? When it is converting to byte code, you won't see all this. Wherever possible, it will do optimization. See how it is going to do that. We can't see the byte code actually, but see, if this is your hello.java, after compilation, you will get hello.class, right? You will get hello.class. In hello.class file, will you see the comments? It will remove the comments in the .class file. No comments available. Remove the comments. Source code has the comments. In the .class file, comments not there. Class okay. Main method nothing. SOP printing okay. Now you have a variable, b variable. Are you using a and b variables anywhere? Are you using a and b variables anywhere? Why to keep that then? Why to keep that? You declared in a program. You declared in the program, guys. That is your developer, your mistake. You did not use this. So compiler is checking. This guy has declared the variable a 10, okay. Assigning to b, up to that, okay. But you are not using b at all. And you are also later not using a at all. Can I remove those? Can I remove those? It removes. And compiler only evaluates this expression. What is the result coming up? 10 by 2, 20 by 2 is the 10, guys. 10 plus 10 is the 20. So the whole result is 20. Okay. Now, how many bytes will be allocated for a C variable? 4 bytes. This is the 1 byte, second byte, 4 bytes like this. Totally 32 bits, right? 32 bits of space is allocated for a variable C. What is the value you are storing in that? What is the value you are storing in that, guys? What is the value you are storing in that? 20. To store 20 in the binary format, internally in the memory means any value you are storing in the memory, that will be stored in the binary format only, right? Because memory is an electronic device, it keeps the values as 1 zeros only. So whatever you are seeing in the high level, 20, 30, everything, it has to keep internal as a binary. What is the binary equivalent of 20? 1, 2, 4, 8, 16. 20 means 16 plus 4 is 20, right? So 1, 0, 1, 0, 0. 1, 0, 1, 0, 0 is a binary value. So how many bits you want to store the 20 value, guys? How many bits you want? Hardly 5 bits. But generally not the 2 bits, Ramesh. 2 bits, no. How many bits you need? 1, 2, 3, 4, 5. But a 5-bit representation is not accepted. Minimum 8-bit representation you have to take. Minimum 8 bits. So this is your 8-bit representation of the binary. So for me, 8 bits enough. 8 bit is enough for me, right? For me, 8 bits enough. To store my value 20, 8 bits enough. But you are reserving 32 bits of space. You are wasting remaining 24 bits of space here, right? So I don't want, compiler will see this. Compiler will see this. And compiler will change the variable C type from integer to byte. In Java, there is a data type called byte, which takes only 1 byte of space. It will change this to byte C equals to 20. Now, how much memory allocated for this program? How much memory will be allocated for this program when I'm running, guys? How much memory will be allocated for this program when you're running? Just 1 byte or 8 bits. See the code, what you have written, how the code is optimized. See how the compiler is intelligent to optimize your code. Space is most important. When you run the program, there are two measurements. Two measurements for any program is time and space. Suppose if I ask you to write a program for doing some algorithm, I asked you to implement some algorithm, right? Now you guys have written, suppose Srinivasdande has written, Chandan has written, Monica has written, and Vishnupriya has written, Vrushali has written, Pavani has written, Durga has written. You, after writing your programs, how can I check which is the better, guys? How can I check which is the better? Whose code is better? Time and space. Time and space. Any algorithm, you have two measurements, time complexity and space complexity. In our data structures topic, we'll discuss so deep about that. So every program, whoever you program you have written, which program is taking less time, which program is eating less memory, that program is the best. Program which is taking less time to give the output and eating the lesser space, occupying the lesser space is the best program to decide. There's no other constraints. There's no recommendations. Some guy has written, so he is MLA son, his program should be best. No. Time and space. Right? This is how optimized, guys. See? Come back. I'll run this program and show you. But you can't observe it, right? See, for example, come here. This hello.java only, I'm changing it. This is your source code. This is your source code. Compile it. Java C hello.java. So you got a .class file. Now if you open .class file, you can't see anything. Let me to remove this actually. Compile successfully. See the .class file is there. Can you open and see .class file, whether it is really optimized or not? You can't understand. Actually, this is the code, it should be there, right? This is the code, how we optimized. I just shown you. This should be like this. But like this, for your understanding, I written a source code, right? Then how to prove this? How to prove, guys? Whether I told right or wrong, you can't see the bytecode and you can't understand. So we have an tools called decompilers. What compiler is doing? What compiler is doing, guys? Your hello.java is converted to hello.class, done by compiler. Throat started paining. Opposite of compilation, decompilation. If you have a dot class file, you can convert to Java using a decompiler. If you want a real version of decompilation, you have to pay money. Decompiler tools are there, some open source tools, some paid tools are there. If you pay money, online subscription, they'll work perfectly. But at a basic level, you don't have to do anything for that. I'll show you some kind of free tools. Come to the browser, have a look. Online decompilers, Java. Yeah, use this Java decompiler online, javadecompilers.com. Go to this website. First one only fine, I think. Second also decompiler.com also okay. Go to this. So which file you have to choose here, guys? Which file you have to choose? Dot class file you choose. Correct? The decompiler. Compiler means compiler input is Java, output is dot class file. For decompiler, input is dot class file, it will give you Java file. So whatever my hello.class compiled here, guys, hello.java compiled, I got hello.class, the bytecode. This I am trying to convert to the Java code. Choose your dot class file. Go to the location where our dot class file is there. Module 1, hello class, yes. And click on upload and decompile. You see the code. Is this looks like whatever we discussed? Where is the variable A? Comment, where are the comments? All comments removed. Means from bytecode, they are bringing the Java code now. In that bytecode, comments not there. In the bytecode, A variable is not there. Bytecode B variable is not there. This is again unnecessary variable. This is also not required. Variable, see, I taken variable name as C only, but they declared as internally var3 variable name as var3 something 20, printing that. A variable declaration, B variable declaration removed. C data type change it to byte because the result is 20. To store 20, 8-bit representation is enough. It is unnecessary to take 32-bit. That's what the data type changed from integer to byte, saving 3 bytes of memory. Do you understand the decompilation process, guys? Now, I will do another change in the program. You answer this. You have to, now you are the compilers. You should become a compiler. You are a compiler. If you are a compiler, how you optimize this code? Tell me. Tell me, guys. This is my byte source code. First, anyway, comments will be removed. Okay. Hello class main method will come. Hello guys will come. Only you see this piece of code. In the source code, you have 5 lines of code like this. In bytecode, what will come? Source code 5 lines are there. In bytecode, what will come? I added 1 line extra now. You see, you act as a compiler. You are the compiler. You are the intelligent compiler. Please optimize my source code. So now, byte A equals to 10 semicolon into B will be removed. So A I am using, right? A I am using. So this line will be there in the bytecode. I am using A. Int A equals to 10. So A is required. But A, I value 10 only. 10 means I need a small, very less, 8 plus 2. So 8-bit representation enough. It has to convert this to byte only. Oh, very good. Then B, I'm not using B anywhere. So B has to be removed, am I right? B is not required. Sunny, you are correct. A equals to 10, B equals to 10, okay, Monica. But B, am I using B? I'm not using B, I'm using A, I'm not using B. So B will be removed. A will be optimized, reducing the size. Is this the line? So this is my guess, correct? You are optimizing. Am I right? 4 lines. For 5 lines, optimized to 4 lines. What changes happened? B not used, removed unnecessarily. Why do you allocate a space? Because of not using, removed, B removed. Then I know that printing, Sandhya, printing in a 2 lines or 1 line, that is the same job actually. That it won't make that optimize. That is not an optimization at all. Optimization means here in terms of memory, majorly memory and time reduction. You printing in a separate line or 2 lines, it won't make any space. It won't make any difference. That's why it won't touch that combination. So that's it. B removed because I'm not using. A value small 10 only. So reduce its size to byte. The result of 10 plus 20 by 2 is a 20. So 20 is a small value. 8-bit is more than enough for that. So reducing C type to this. Okay, fine. That is the case. That is the case. So I will recompile this. First compile. Compile. I'll go to DeCompiler. I will go to DeCompiler to get a new file. Again, I'm uploading the new file and check. Am I right? Yes or no, guys? Everything same as we done. Okay. All right. I'll give one more task for you. Have you heard about a final variables? Final int A equals to 99. This is the code. Can you do optimization for me, please? Only have to think about A. Yeah, B will be removed. That is anyway okay. Previous option as it is. Regarding this, whatever capital A I declared, final variables declared as a capital A. Will it make A to byte? Will it do something like this? Are you saying something like this? Is that? Final keyword will not be changed. Okay, keep it final also there. Is that? Is that the change? When you use final, that will not convert the data type. Bargo. Guess is that. Okay. B is removed anyway, Monica. See, B is removed. This is my hello.class. This is my byte code. A taken. In the source code, A int A 10 is there. I change it optimized to byte A. Here B removed. This is int C. Change it to byte C. And int A is there. Change it to byte A. So 99 is the 99 can be accommodated in the byte only. Harshini. Byte 8 bits takes the maximum of 127. Byte max range is 127. You can store up to 127 in the 8-bit representation. Or take 9 only. Don't think on that. Keep 9 only. 9 can be stored in byte, right? 99 also can be stored in the byte. Okay, actually, anyway, we'll discuss about final variables. We have every topic, we have clear explanation, labs, everything. I'll tell you one. Anyway, I just wanted to check, maybe you have some knowledge on Java, whether you can guess this or not. Right. Final variables are again source code level. I'm giving a hint to you. Final variables are source code level only. Final variables are source code level only. What is the meaning of that? Final variables are source code level only. What is the meaning of that? Means what happens is your final, wherever final variable is declared, final variable occurrences A equals to 9, where is occurred? Final variable occurrences will be replaced with the value, and final variable declaration itself will be removed. See, wherever A is used, wherever capital A used, what is the value of capital A? Can I change that? Because of final, I can't change, I can't modify it, right? So it will keep replace the A with 9. Then what is the use of A variable? What is the use of A variable, guys? A variable, change it to 9. Any need to declare the variable A final? Not required. See, the declaration itself removed. Final variable declarations will be removed, and that is mainly local. Still, there are other combinations of variables. Variables can be local, instance, static. There again, we'll see more deeper. Currently, this is a local variable because declared in the main method. Just remember blindly, this is a local variable declared in the main method. Local final variable declarations will be removed. Simply, you print the wherever A variable you used, wherever that final variable you used, all the occurrences will be replaced simply with the 9. Simply with the 9. Then occurrences, A variable is not at all used, right? Wherever capital A is there, I'm replacing that with the original value 9. Then why the variable declaration required? Not required. Remove that and see the optimization. How my compiler tells. This is my source code. Compiling it again. So I got output anyway. Just 4 lines, I got output. It comes. But the output anyway, we know that is not our goal, right? Our goal is to decompile it. Upload our fresh.class file and decompile it. See, guys, is that optimized? Do you have the final variable declaration anywhere? JVM don't like final variables. Just consider like that. Final variables are source code level. Comments are source code level. You will not see the comments and final variables in the byte code at all. Got the point? That is the still many things are. This is an introduction part. Just I given how it is intelligently optimizing a code. Lot of things are there. Lot of things. So like this, if you want to learn every Java program for core Java only, I need a 1 year time for only core Java to teach the every level of optimization, because I know what JVM is doing internally, what compiler is doing internally. I worked in a Sun Microsystems, I told you, right? So I was in R&D team. So I can teach 1 year only core Java, going everything deeper and deeper internally, what is happening. That is, I told you, I think at the introduction part, some of the things I teach, you will not find anywhere in any book or any website or any YouTube channel, because this is from experience. You can't just read it from. By doing, I learned many things. Fine, anyway. So I can tell more things about me, right? Always. I may not tell on the way. Wonderful, guys. That's about optimization. We have done this. So Java introduction part is completed, guys. Java introduction part is completed. I thought to do the assignment for you, but I think it seems now if I start assignment, it will take 1.5 hours, more than 1.5 hours. So can I upload the previous batch assignment video so that you can see instead of doing now? Just for answering questions only. Nothing is there in that. You see I'll show you the questions. I'll show you the questions, guys. Quickly, I'll just show you how it looks. The assignment. Right, so these are assignment questions. I think I answered already here. C program is a platform independent. You have to answer it true or false. C program is platform independent. No, false, right? So like this I given. Now, second question. I have written a Java program and compiled with Java 9. I have written a Java program and compiled with Java 9. Can I execute that with Java 8 JVM? And I given answers anyway. This like this. These are the kind of tricky questions, simple questions, but I explained. After this, I'll attach that video also. You can have a look. So how can I check? I'm compiling on Java 8. Can I run on Java 9 to check the compatibilities? 2 questions. And how can I check the current version of Java compiler I am using? How can I check the JVM version I am using? And for this error, what is the reason for this error? What is the reason for this error? What is the reason for this error? Right? These questions, what is the reason for this error? When you will get it? Only when you do practice. When you do practice, you understand. When you're doing practice, you'll you'll do mistakes, you'll do errors. And when I'm doing also, I've shown some errors. Those are all explained and answers also given, guys, here. Whether you setting class path, all questions answered. But anyway, in video, I have a clear explanation of that. So you have a look. Can I have multiple JDKs? Yes. Can I have multiple JREs? Yes. Can I install only JRE? I don't want JDK, only JRE I want. Is that possible? Yes, you can. You download only JRE, you can install it. So these some questions we have done it. And question number 30 is about difference between C++ and Java. They may not ask in the interview, but one question for you. Around 12 things I have explained here. So these are all questions explained in the previous batch. Again, instead of spending I think maybe 1.5 hours regarding the same questions, the previous batch video I'll upload next to this session. Okay, so you go through that. This booklet I'll send it to you. You go through that, and so that we can start the module 2 in the next session. Okay, guys, that's the end of module 1. We'll see you in the next session. Thank you. Have a nice day.